So this is Chapter 3, Lecture 2. We finished off on the bottom of page 2, and now a quick look at the chart for properties of copper. So we talked about physical properties and chemical properties. Physical properties of copper would be something like it is a reddish brown or shiny. It can easily shape into sheets, good conductor of heat and electricity, and density with a value, melting point, and boiling point. So those are physical properties. Chemical properties of copper include reacts and forms copper carbonate compounds in air. It can react with nitric acid. It can form deep blue solutions with ammonia. So it's some kind of a reaction to describe a chemical property. What we're more interested in is the changes that a substance will undergo. So we can have a physical change or a chemical change. A physical change will alter the substance without changing its composition, what it's made of. So cutting. If you cut whatever, a piece of steak, it's still steak. If you cut a piece of paper, it's still paper. Breaking. If you break glass, you still have glass. Melting. So if you melt ice, you still have H2O. It's just in the liquid phase and not the solid phase. All phase changes are physical changes. So pH for phase, pH for physical. All phase changes, melting, boiling, freezing. We're going to discuss sublimation, going directly from the solid phase to the gas phase. These are all physical changes. So here's two definitions. The melting point, the temperature at which the phase changes from solid to liquid. A melting point is an intensive property. It's unique to the particular substance. Ice melts at 0 degrees Celsius. If you have a substance that melts at 0 degrees Celsius, it has to be H2O. Boiling point is the temperature in which we change from the liquid phase to the gaseous phase. It is also an intensive property. Chemical changes are changes that result in the formation of new substances. We call this a chemical reaction. Examples: exploding or explode. These are the cool words. Chemical changes are usually the cool things that we want to see. Decompose, corrode. So when this happens, we have a chemical change. We say the reactants turn into products. During any kind of change, physical or chemical, there is a conservation of mass. Mass is neither created nor destroyed during a chemical reaction. It is one of our fundamental concepts of chemistry. So if we look at this chart, we see that there was a reaction between aluminum and bromine. 10.3 grams of aluminum react because there's nothing left over. But of the 100 grams of bromine, 8.2 grams were left after the reaction. So how many grams of bromine reacted? 100 minus 8.2, what's left over, is 91.8 grams reacted. So how many grams of the compound formed? So we used 10.3 grams of aluminum. We used 91.8 grams of bromine. So when we add it together, we used up 102.1 grams of reactants. Conservation of mass tells us if you used up 102.1 grams of reactants, then you must form 102.1 grams of products. And that's conservation of mass. Our last term for today is entropy. Entropy is a measure of disorder in a system. If your disorder increases, your entropy increases. So is there an increase or decrease in entropy in the following processes? So solid to gas, that's more disorder. So that is an increase in entropy. Gas to liquid. So a gas condenses to the liquid phase, it's more orderly, so that is a decrease in entropy. So pause the video and go ahead and fill the rest of these out. Melting, liquid or solid to liquid, is an increase in entropy. Boiling, liquid to gas, is an increase in entropy. If something burns, it turns into smoke and ash. That's an increase in entropy. Freezing, we go from the liquid phase to the solid phase. A solid is more orderly, so that is a decrease in entropy. Here we look at the symbols, and we have a solid going to a gas, so that is an increase. Here we have a gas and a gas turning into a liquid, so that is a decrease. And here we have order going to disorder, so that is an increase in entropy. So that is it for today's lesson, and we will see you tomorrow in class.